to the final GEOSTRATA Extra of 2023. My name is Brad Keeler. I'm the director of the Geo-Institute, and we are thrilled to welcome you to another amazing Geo-Institute live stream. Of course, you've seen our other content, you've seen our recorded content, you've seen our live content. We're very happy to welcome you here today. If you stumbled upon us and you don't know anything about the Geo-Institute, after you watch this excellent interview today, you should head over to geoinstitute.org, and there you will discover many, many things about us, including that we are a technical society with about 12,000 members, most of whom are geotechnical engineers and/or geologists, and that we are part of the American Society of Civil Engineers. If you like what you see today, and I always feel very strongly that you will, viewers, you should do these things in this order. You should click like, subscribe, and get notifications, and we will let you know every time we post something to the YouTube channel, which is valuable information to have. A couple of things before we get started here. It is, if you consult your trusty calendar, almost the holidays. It is almost the end of the year. It is a great time to make your contribution to Geo-Institute student programs. 100% of what you donate is tax deductible, and 100% goes to support our student programs. If you contribute at least $96, you get to choose a couple of really cool items from a couple of really cool items. We have less than 10 Carl Terzaghi bobbleheads left. So if you want one, this is the time to do it. You can also choose Geo-Institute socks. We have Carl Terzaghi 60th anniversary of the Terzaghi lecture pins and other things that you can choose from as well. You can do that at geoinstitute.org. Now, GEOSTRATA Extra, what is it, you may ask? 6 times a year, we publish our flagship magazine, GEOSTRATA. That's your cue, guys. Yeah! Every other month, one of those issues is on its way to all GI members' mailboxes. It arrives by boat, by plane, by train, perhaps by truck sometimes. And inside is all kinds of amazing information that you can only get by reading GEOSTRATA. Member news, member notes, high-quality articles, and they all have an amazing theme. So, every single issue, we go behind an article with one of our authors. An editor does the interview, and today is no exception. Editor Mary Nodine of the Federal Highway Administration will be interviewing Jean Benoît of the University of New Hampshire about his piece in the December-January article, Measurement While Drilling, Listening to the Rig. Look at that, Mary's right there with the prop. It's like we rehearsed this, guys. That's all I have to say today. Mary, Jean, it's time for you guys to do your thing. Thanks for doing this, guys.
You're welcome, Santa.
Thanks for having us, Brad. All right. Welcome to the latest episode of GEOSTRATA Extra. As Brad said, in this series, one of the GEOSTRATA magazine editors, that's me, will interview an author in the most recently published issue. That is Jean here. We use these sessions to delve more deeply into one article and to get the author's added insights on that article and the overall theme of the issue. My name is Mary Nodine, and I am a geotechnical engineer with the Federal Highway Administration Resource Center. I've been a GEOSTRATA editor for 7 years, and I've been the magazine's resident geopoet somehow since 2008. All right, so the December-January 2023 issue of GEOSTRATA has a theme that many of you may not be familiar with, or maybe some of you are here because you are familiar with it. But the theme of that issue is measurement while drilling. And those of you who are not familiar, or sorry, those of you who are familiar with it may know more about MWD from foundation drilling and may not be aware that the use of MWD is also popular in some places and more in the United States on exploration rigs. So I'm personally really proud of this issue because our editor-in-chief, Jim Withiam, was skeptical that we could actually get enough content for a whole issue on MWD after I suggested it maybe at this point it was over a year ago, but I was pretty confident from my work with FHWA's A-Game initiative that has been promoting MWD for quite a while now, that we could pull something together. And I think the published issue came out really great, and hopefully will open a lot of people's eyes to the benefits of MWD. All right, today I will be speaking with Jean Benoît, who co-authored the issue's lead article, Measurement While Drilling, Listening to the Rig, with PhD student Bruma Souza. His article delves into the basics of MWD, and it's a great introduction for those of you who aren't familiar with the technology. Here is a little background on Jean. Professor Benoit has been at the University of New Hampshire since 1983 and an Emeritus Professor since May 2021. He received his Bachelor of Engineering in Civil Engineering from Ecole Polytechnique in Montreal in 1977, and his Masters and Doctorate in Civil Engineering from Stanford in 1980 and 1984. He has expertise in geotechnical, geological, and geoenvironmental engineering, and has published extensively on these topics, especially in the areas of in situ testing, which of course we're going to be talking about today. Prior to arriving at UNH, Professor Benoit worked in industry for Woodward-Clyde on projects in the US and overseas, and he took 2 sabbaticals and has held faculty and research positions at several French universities and conducted research at ISMES in Italy. So, welcome, Dr. Benoit. In this episode, we're going to delve deeper into Jean's article and his experience with MWD. If you have questions for Jean, I encourage you to type them right into the comments for this video while you watch, and we will do our best to address those questions as time allows. All right, so first, for anyone who hasn't gotten their hands on the issue yet or hasn't had a chance to read it, could you give an overview of what MWD is and why it's useful, and what information we can glean from this technology as geotechnical engineers?
All right. Well, thank you, Mary. Thank you for the invitation to do this. So I think the best way to get started in there is I have a few slides, and the whole extra is not going to be all slides, just a few slides to get started to explain what MWD is. Basically, it's the interaction between the imposed drilling method and the ground response. So let me share my screen. Hopefully I can do this properly. There we go.
Pressure. There you go.
I know, pressure. So I got to put this in some sort of mode like that, maybe. Is that okay?
No, you guys share the other screen.
Okay, hang on. Yeah, I was doing good for a little bit.
Okay, everyone's patient. We have a sympathetic audience out here.
Okay, hang on. Hang on.
You want to unshare and share your other screen.
Unshare it. Okay. And then open it. All right. Come on. Sorry. Now, display setting maybe. Swap. That is.
Just share your other. Go to share again and share your other monitor.
All right. Share again and do that one. How's that?
That's this. It looks like the same monitor.
Okay. That is not better. Can you see
Try
it?
one more time. Then maybe you
okay.
can send them to me and I can share them.
Yeah. That's the only thing we didn't practice. So unshare that, right? Stop sharing. Okay. Now you want me to go and do it in presentation mode.
Do you have a monitor that's not vertical, that's like sideways?
That's why.
That's the one you want.
Problem. Okay. We're going to do that. That's why, because my monitor is up. So we're going to do it that way. That's why it is. Okay. So now that should do, right? How's that?
There you go. Now put it in presentation mode and see what happens.
Okay. Maybe. There we go.
All right, Brad can edit that out when he.
Is that okay now?
Right. Yeah, it looks great. Go on. Tell us
all
about
right.
MWD.
So sorry about all of that, but I do have one screen that I leave vertical for various reasons. But anyhow, so what is measurement while drilling? It's a continuous and automatic recording of all aspects of drilling. And you do that at depth interval 15 to 20 millimeter, whatever you choose to do. And that's using a series of sensors that are installed on any conventional drill rig. The whole system doesn't really interfere with the drilling operation, and you get a real-time display of the drilling progress. And all the data that you acquire is stored electronically so that you can manipulate it later in the office or in the field if you have your field computer in there. So what are the various sensors that we put on a drill rig? We have a sensor that does the advance rate, so how fast you're going in the ground, the down thrust, so the pressure that you apply on the tool to drill. The whole back pressure, this is something where if you go fairly deep, you have a lot of weight, all the rods are heavy, and so you might, or you have very soft soil, you might want to hold back that thrust. So that's the whole back pressure. Typically on geotech, we don't need to use that because we don't go that deep. Torque sensor, rotation rate, how many RPM. If you do percussion type drilling, you can measure that, measure the injection pressure. So the fluid that you use, whether it's water or water bentonite or air. So the fluid injection pressure and the fluid flow, which you could do the flow into the borehole and the flow out of the borehole. And all of that is tied into a junction box. All these cables come in and plug into this box, and the box is connected to a drilling parameter recorder, which you can see in here. Okay.
Sounds good.
So this is actually a slide that a figure that's in the article, modified a little bit, add a couple of things, but you have the drill rig in here. This is the New Hampshire DOT drill rig. It's a CME 45C, and you have the recorder in here. This is our computer. You don't need a computer, you just need this, but this is our computer in here. The junction box is right there. And then we have the various sensors installed here and in there. So you have the junction box, the data logger, the thrust pressure. So these are, whether you have a mechanical rig or a hydraulic rig, you can measure the pressure in the system. So in this case here, you're measuring the hydraulic pressure. So you're measuring the thrust in there. You have a similar sensor that measures the water pressure. You have a torque sensor in here that fits right on top of the drill rod. So this is a new thing that we're working with now. So that's very exciting. We have a rotation sensor in here. So that could be a sensor that reads the number of bolts on the drill head. Sorry, as the drill head rotates, it looks at the it's electromagnetic, so it looks at the bolts, counts the number of bolts, and we can enter in the computer in the logger that say 12 bolts is one rotation. So we can monitor the rotation speed that way. We have the flow meter in here, the depth sensor, which is located at the top, and we could also have a flow meter out. So whatever comes out of the borehole, we could put a T connection in there and run it through, so that if we lose any sort of fluid in the formation, this would help us know that.
Right.
Here's
so
a
the
little
main purpose
video.
of all this, is to
Yeah,
watch
there
over
we
the
go.
driller's shoulder and make sure that he's doing everything right, right?
So this is just
Okay.
the torque sensors in there, and this is the data logger. So the driller is looking at that.
Yeah.
Okay. Sorry for all the noise in there, but
Oh no,
so,
we couldn't hear the noise. You didn't share your noise.
oh, okay, but that's
Just
okay.
heard me
It's
asking.
it's better not to have the noise. That way you can hear that.
Yeah,
you're not
so it's a
deaf
lot
like
of
I am.
information, and it does not get in the way of the drilling.
Right.
Awesome. Go ahead.
So the drilling parameters, there's different types of drilling parameters. There's those that are imposed by the drilling method. Okay, so what kind of tool you use, the diameter of the tool, the limits of the machine in terms of performance, what injection fluid you're going to use, and what fluid type. And then you have the machine parameters. Okay, so those are controlled by the operator, by the driller. So how much thrust you put on the drilling tool, how fast you rotate, and what kind of fluid flow rate you put in there. So you're putting 5 gallon, 10 gallons per minute, or liters per minute if you want. And then you have the ground response from that drilling. So how fast, so you apply a thrust, how fast is that going to go in the ground? So that's the advance rate. How much torque does it require to cut that material? What is the fluid injection pressure, the mud pressure? What comes out of the hole and the hole back pressure? And then you have the non-control parameters that the tool will wear. You can see here at the bottom right, this is a new tricone bit, and this is a tricone bit, that the same one actually, the same type, but this was after just 15 feet of drilling. So it was obviously not the right combination of parameters feet? To advance the hole.
That's after 15 feet?
15 feet, yeah.
Wow, okay.
Yeah, exactly. Well, soils in the Northeast can be a little tough. And then changes in fluid composition, that's another parameter. So this is what you get roughly, okay? So on the right side in here, you have the monitor, and you can see here you have the moving speed, you have the rotation force, injection pressure, down pressure, rotation speed in here, and then the force sensor, the thrust. And you can put anything you want in here. You can put them in any order you want, but this is what the driller and the geotechnical engineer or the geologist will see as the hole is progressing. You have the depth in here. So you have, in this case here, you have a torque sensor, and then you have the hydraulic down thrust in here, which is fairly constant because that is measuring the pressure in the hydraulic system of the rig. But if we actually go and measure the thrust at the top of the rod, you can see that it's very different. So this is where we're heading. We'll talk about that a little bit later, but this is where we're heading. We're trying to make the measurements right at the top of the rods so that it will be a lot more accurate. And these are, this is the data that you get. It's a little bit manipulated in terms of looking at some parameters in here that I'll explain in a second, but here we can display these various parameters: drilling rate, rotation rate, water flow, water pressure, down pressure, torque. So basically taking what we see on the screen, put it here with the software, and get a really, really nice picture of what goes on in the subsurface. So you can see in here the water pressure. You can see it's a stiff clay in there. And then we match this with adjacent SPT borehole. And so you have the SPT values there in black, and then you have the recovery in percent. So we can use all that information to get some geotechnical parameters. And so this was in soil, and this was the continuation, but in rock in here, and we compare it with the RQD. I know this is a little fast, but of course, when you measure all these parameters, every driller will operate differently. We'll use different ways of advancing the borehole. So to try to normalize that information, we use something called compound parameters. So it's a combination of individual parameters into indices of energy or some other index in here, alteration index, and so forth. So it depends on when they were introduced and for what purpose. So there are a number of compound parameters in there, and these will eventually improve as we make the measurements at the top of the drill rod. So there'll be less correction. So why? Mary asked, why do we need this? Well, this is, I found that a long time ago from the Corps of Engineer. A major part of field investigation is a compilation of accurate borehole logs on which subsequent geologic and geotechnical information, the decisions are based. Okay, a field drilling log for each borehole can provide an accurate and comprehensive record of the lithology and stratigraphy of soils and rock encountered in the borehole and other relevant information obtained during drilling, sampling, and in situ testing. So that's what we're doing. And it says here, to accomplish this objective, an experienced geologist, soils engineer, or civil engineer with good geotechnical training and experience should be present during drilling. Of course, that doesn't always happen because that's usually the first job for a fresh out of school geotechnical engineer. So they don't necessarily have the experience, but they will gain it. And MWD would help them greatly on that. So MWD turns this blind operation of drilling into a qualitative and quantitative picture of the subsurface. So when do we do this? When we want to get accurate geologic profiling, we want to characterize the soil and the rock. We're looking maybe for voids, fissures, or other anomalies. Say we're going to be grouting. We want to look for those. We're going to certainly improve the drilling efficiency, how we advance a hole with minimal energy, how we get high quality core samples, how we can optimize the quality of the borehole so that we can go back in the borehole later and run maybe some geophysical tests and some Packer tests. It will help managing the drilling operation, and certainly will improve the communication between the driller and the engineer or the geologist. So it's there to complement what we're doing. It's not meant to replace everything else that we've been doing. Okay.
Yeah, and I think a lot of those points that you have towards the end are really compelling benefits to it that people don't necessarily think about, like improving the drilling efficiency. That's hard to argue with. And my understanding is a lot of drillers haven't been as open-minded maybe as we'd like to this kind of stuff, because they were like, I don't want you telling me how to do my job, but at the same time we can learn a lot from it, and it can make drilling happen more easily, more efficiently. So yeah, it's great stuff, and thank you for that presentation.
Oh, welcome.
All right, so I think of you, I've known you, I guess now since I started working on the A-game stuff back in, I don't know, 2020 or something like that. And I think of you as an MWD authority of sorts, and maybe a pioneer, which I'm not sure why I think that, but it's just sort of how you've come across to me. And I admit I don't actually know the story of your involvement with the technology. So I'm curious if you would share with us your background with MWD for subsurface exploration and how you first started getting involved with research on this technology.
Okay. I've been involved in drilling for a long time. When I was an undergrad at Ecole Polytechnique, even before I had geotechnical courses, I spent 2 summers working for an engineering firm working up north in Canada. I know Canada is north, but really up north, like 1,000 miles north of Montreal. So I worked on the James Bay project in '74, it was a big hydro project, and I worked on the, the Lower Churchill Dam in Labrador in '75. So I spent all my summers while I and my friend were having fun in Montreal. I was out in a tent someplace and getting to the drill sites by helicopter every day, and spending 12-hour shifts 7 days a week. So I had a lot of fun, and we're going through in James Bay with soil, about 100 feet of soil, and in Labrador over 500-600 feet of rock. Wow. And doing this without wire lines. So when you were at 500 feet, you would drill 10 feet, pull out 500 feet of rod, get the sample, and go back in. So, but where I'm getting at is I got really interested in drilling, and then because we were in the middle of nowhere, the drillers would teach me how to drill. So I had a lot of fun. And in Labrador, one day, well, they told us to get ready because we had an expert coming in to take a look at the core. So we lined up all the core boxes in order and everything. And this expert turned out to be Ralph Peck. So Dr. Peck, which, I didn't know it, I'd never had geotechnical courses. I didn't know who he was, but everybody said he was a real expert.
He just showed up and you didn't know who he was.
No, exactly. He showed up in a helicopter. We were waiting for him. He came out and talked with us. It was really nice. And I talked to him after, years after, and you remember and everything. It was great. But he came in and looked at the course and I was like, oh, this is really cool. So I really got excited about this stuff. And so anyhow, now go 20 plus years after, I had a sabbatical in France and in Italy. And in Italy, we were working along the Po River for another project I was involved with. And then all of a sudden I see this system. It was called Papero, like paper. And it was an MWD system, Italian made. And it was pretty bulky, and everybody explained to me what it did. And so it was really cool, with strip chart, that type of thing. Really, this was in the late no, I'm sorry, this is in 92.
Oh, 92.
In 92. So I came back and gave a presentation to a GIS workshop, and then Cliff Astle, who was the NSF director at the time, the seismic side, said, this is great, you should write a proposal. So I did, and reviews came back, and the reviewer said, this is too practical. And it's really technology transfer. We shouldn't really fund this. So basically, didn't have enough equations in there. So I just kept plugging away, and eventually we got a project funded by EPA to look at contamination of bedrock at Pease Air Force Base here in Portsmouth, New Hampshire. And then I suggested to my colleagues in environmental that we should get MWD system so that we could locate fractures so that we could go and do the bioremediation in the fractures. So we bought the system, and that's really how it really started. That was late 90s and early 2000. This is when we got started. And I've had several, I want to acknowledge all the students that I work with. They've been great. My colleague in France, Philippe Reifsteck, my current student, Ruma Souza. Well, actually, you say her name better than I do. Mary.
I think I said it Souza.
Souza. So thank you for that. She'll appreciate that. So anyway, they've been a big part of this. So awesome. That's the story. It's a little long, but.
No, so you really were a pioneer in the United States with this stuff. You've been doing it for a long time. It's pretty cool. So it must be nice to finally see it starting to take off.
Yes.
Are you like finally?
It's like, yeah, now that I'm retired. Yeah, great. Good timing.
Come speak for us. Yeah, you're traveling all over the country doing this stuff now that you're not wanting to work anymore. But we're glad you're still engaged. Okay, so we have a couple of questions from the audience here. So I'm going to interrupt our regularly scheduled program to ask them.
Okay.
We had the question, can you use MWD for SPTs to save us from counting?
Well, I mean, we can talk about that, definitely. We want SPT. Definitely, that's not something that we can just throw to the side and say we don't want to do SPT anymore, because SPT is simple, and you get a sample. That you need that. So what it can do, though, with MWD is to minimize the amount of holes we do with SPT, and that's very valuable. We did a borehole a couple months ago, down to 95 feet. And we did that in just, if you calculate the drilling time, in less than an hour, we were done, basically.
Right, with no samples.
Yeah, with no samples. But we need samples to be able to correlate with the measurements that we get. Eventually we'll even need less and less of the other testing. But right now, it's still, even if I've been involved in it for a long time, it's still in its infancy, really.
Right, sort of like with CPTs, like you need to get some samples to calibrate yourself, but then you can do a bunch of other holes. And so in conditions where CPT is not appropriate, I think SPTs are really, MWD is really valuable there.
Yes, absolutely.
Okay, so the next question is, when considering drilling that includes hammering action or sonic, is there a compound equation that are applicable to this specific scenario?
Yeah, there are compound parameters, and we don't do a lot of percussion drilling in this country, but they do a lot in Europe. So I know in France is their main way of drilling. So yes, there are some compound parameters that deal with the percussion.
Okay, awesome. One more question. When identifying discontinuities using MWD, is there anything other than depth that can be identified for a given discontinuity? So I guess he's saying like other characteristics.
Well,
I'm
I
not
think,
exactly sure what he's asking.
yeah, I mean, what you can say is yeah, you can locate, and you can also get an idea how much fluid you lose in the formation. So if you have a flow meter for the outflow, then what we've done on a project and in Boston actually, and then in Portsmouth also, is we look at the difference between the inflow and the outflow, and that will give you an idea how big that fracture is.
Mhm.
So, you know, how conductive it is. So not only there's a void in there, but can it conduct water?
Right. So you can get a sense for whether it's a big one or a small one.
Right.
Yeah, you can use a televiewer and really get to see it if you want to.
You can, and we've done that also. We did some comparison in there. But also, you know, you want to make sure that you're doing the drilling properly so that you're not creating something artificial in there, you know.
Yeah. So another question I had was why do you think so many practitioners in the US are still using SPT as their primary subsurface characterization tool? And is there a difference in how US practitioners approach subsurface explorations versus, say, Europe in terms of prioritizing various techniques? I'm curious what your take on that would be.
Well, I mean, like I said, SPT is simple. You get a sample. There's a lot of legacy data also, and it's very conservative. You look at you know, when I was in undergrad, we had the textbook was Terzaghi, Peck, Hansen, and Thornburn. Okay, so so that textbook only dealt with SPT. We didn't have any other tools then, so all the design that we learned was based on the SPT. And, you know, there's not a lot of failures of you know, small, medium-sized foundation using SPT. So there's a lot of legacy in there. So that a lot of history behind the SPT. In Europe, they also have different soil condition, or there's a lot of rock. In France, I know they're using MWD because there are a lot of places they can't use SPT. And in France, in particular, they use the pressure meter. So the pressure meter, you know, they're very nationalistic. So the pressure meter was invented in France. So they use that pressure meter almost like we use the SPT. So they have a lot of confidence in the pressure meter. And actually, they have codes and manuals that go directly from the measurements that they do in the field to the design. So it's a direct thing. They don't go and take the pressure meter data and come up with the geotechnical parameter, then put that into your bearing capacity equation, for instance. No, they go directly from the test to the design. So it's a different philosophy altogether in there.
Yeah, that's actually those are actually interesting perspectives on it. But yeah, and it's like it's sort of a big hurdle we have to overcome in terms of what people are used to doing and what kind of correlations and such are available and out there for people to use. But I think we've come a long way.
Yes.
And hopefully MWD will be a part of that as we transition forward, along with CPTs and other tools. Pressure meter is an awesome tool too.
And MWD also was developed for deeper holes. So a lot of it was for rock, not for soil. So now we're venturing into a new area.
So a lot of people, I guess myself included, especially when I first heard about this technology, get hung up on the fact that measurements from MWD are not absolute or easily correlated with soil properties the way CPT seems to be, where it's like a calibrated instrument, it's done the same way every time. So it sort of feels like the need for calibrated equipment is a little bit at odds with what we have out there for drilling equipment and the way we typically approach drilling. And that it feels like that would limit the utility of the technology for everyday practitioners. So how would you respond to someone who believes that MWD is too complicated to meet their needs?
Yeah, I think, first of all, I don't think Personally, I don't think it's complicated. We've been able to use this very effectively and very easily. If you look at the history of the CPT, the cone penetration test, that started in 1932, I think. And so that was the mechanical cone. And then they did, they correlated to some other tests. And then it came the electric cone, and it came the piezo cone in the 70s. And then in the 80s came out with some correction on equal areas, that type of thing, to go from QC to QT. I know it's a little technical here, but anyhow, there's 50, 60 years of time before we get to a point where we can actually use that data from the cone effectively, get an idea of soil behavior and strength. And we're still creating new correlation with the cone. We're not done. So really, we're just starting with the MWD, and I think it's not complicated. A lot of the technology is there right now. We're improving the instrumentation. We got better sensor, better location of sensors, and I think we're going to start building a database in there and case histories where we'll have a lot more confidence. We've made some comparison with the SPT, and the comparisons are really excellent. So no, it's not complicated at all.
But how do you think having, say, your like a state DOT that didn't have any local correlations yet, what do you think that they could find useful about MWD kind of like right out of the box? Is there anything?
Well, yeah, I mean, right out of the box, working with, say, the New Hampshire DOT, they can actually see how they're drilling. And this is something that they haven't been able to see before. They just put a hole in there, but they don't know the quality of the borehole and how they're actually doing the drilling. If you ask a driller, for instance, what's the RPM? A lot of times they're going to be way off. They have no idea if they're going, 80 or 180. They're just sort of go by feel, right? They had the experience, but now they can actually fine tune their drilling and see what comes out of the hole and, what do I need to do to make this more efficient? And they can see all the parameters in front of them and make these adjustments. And then so they're starting to see the benefit. And also, one thing that's very important is bringing this technology will actually encourage younger people to get into drilling and see that it's more technical area than just, somebody that's going to lift rods all day and pound some holes. They can learn a lot from that technology and become more proficient, really.
Yeah, I think those are great points. And I think those are good selling points to, say, a drilling company or a consultant with drillers to get the systems installed, even if it's not a particular requirement by their client. It's like they would have that data and then be able to use it to improve their practices, as well as having it be a selling point to clients. So those are very good points. Yeah.
And they may actually, save on repair and maintenance of the rig by doing, not overly charging the rig to do a borehole, but really, work within the parameters of the rig and get the hole down more efficiently. They won't break the rig as often.
Yeah, that makes a lot of sense, and I'm sure it's something people think about even more with foundation drilling. But for exploration drilling, it's a really key point too. All right, I have a few more questions, so I don't want to get too behind on the questions. So I'm going to go back to some of the audience questions.
Okay.
So someone asked, following up on the discontinuity question, do you have any experience, I don't know if I'm pronouncing this right, any experience carrying out a Lujan test during MWD? Yeah,
Lujan test.
So that's why I couldn't pronounce it.
It's a French test, but basically it's a Packard test.
Oh, okay.
We didn't do too many though, so we didn't go too far in that. This is something maybe we should go back and take a look. But essentially what this person is talking about is going into a cored borehole and then running a permeability test So you could have a packer at the top, and say if you have a double packer system at the top and at the bottom, and pressurize the middle, so you can actually find, you could use this for hydraulic fracturing, so find the strength of the material, and also for permeability. But yes, you can definitely do that. And that was something we did for the EPA project. We wanted to see how these fractures, these discontinuities would react to pressure and injection of material to fight the contaminants.
So I would imagine that MWD could probably help you identify the depths for those types of tests.
Absolutely.
Better, like once
absolutely.
Before you went back down, because you'd have more information about different areas, the different depths and fractures. There was another one related to fractures. When you were commenting on the ability to delineate fractures and flow through fractures, you alluded to being careful about artificially created issues. Can you elaborate on this?
Say that again. Be careful
When you were commenting on the ability to delineate fractures and flow through fractures, you alluded to being careful about artificially created issues.
Right. So what I meant by that is if the drilling is not done appropriately, then you might be creating you might enlarge the hole in some areas, create some fractures, maybe break some of the material in there in the borehole. That's what I meant. So MWD will help us drill the hole with not minimal disturbance, because you're really putting a hole in there, but you're not enlarging the hole or eroding the hole, so that you can use it later for testing. For instance, you could do a pressure meter, a high pressure pressure meter, which is called a dilatometer, also a little confusing with the soil dilatometer, but it's a high pressure test, so you can go in there, expand the membrane against the borehole, and then get your stress strain curve in there. So if you have a good hole, there'll be, you'll be able to get a better idea what the modulus of the material is and the strength of the material.
Okay, that makes sense. The next question, which kind of leads into, I wanted to talk about things like research and future of MWD. The viewer says, I see an advantage of MWD assisting in reducing the amount of samples needed, but I don't see how we can eliminate them. I don't think that that's what you were implying. It was more like that we would do samples, but don't need to do as many. So I agree with that. But he also says,
and if I can add something to that, I think a lot of times people think that they can just look at the cuttings and know what's going on in the ground, but that doesn't really work. The cuttings, when you get them, you already past that zone. You don't know if you have enough flow to bring everything up. So you might be getting some sand up, but you're not getting anything else. So just using cuttings is not enough. So no, we do need adjacent boreholes where we could do some sampling and then really try to understand the MWD parameters that way.
Right. So it's like an MWD hole and then an adjacent
SPT or whatever.
And then you could do like 5 other MWD holes in the vicinity and get a sense for the variability.
Right.
So this person also says, I don't see the correlation between MWD output and soil strengths, et cetera. And I think that kind of leads into the question of research going on in MWD and where are we going with getting better, like actually connecting it more directly to things like soil strength and parameters that people need for design.
Right. Well, if we talk about research, there's a lot of work that's being done right now. Some of it has to do with trying to correlate MWD parameters to unconfined compressive strength of rock. And so I know the University of Florida, Dr. Rogers, been working on that quite a bit. And the idea is, and if you look at that beautiful issue here, you'll find some pictures of what happened when your drilling is not done properly. You end up with core samples that are deteriorated. eroded, you can't really get a strength out of this. So, but if we work within the operational limits of the rig and really make a nice hole so we can get some good cores, then all of a sudden we can take those cores, run some unconfined test, get some values, and then compare that to the parameters that we get. Okay, so we can do a compound parameter and then compare the value of the compound parameter with the QU from the lab testing, and we start building a database. And it's especially important if you're working in the same area, the same type of material, your database is going to get better and better. And we did that in Boston on a project where they were concerned that the cores that were coming out of the hole and the RQD that they were measuring were really too low. They didn't believe that the rock was that bad. In Boston, it's a argillite, so it splits up fairly easily. So they asked me to go in there. We did some MWD, and then we were able to determine, okay, what were the parameters that we needed, that we were getting when the rock core was really good. So we could do those comparisons, and we ended up showing that a lot of the fractures that we saw coming out of the ground were drilling induced. And so because of that, they were able to reduce the length of the caissons for their foundation. This is for a high-rise building, and this is back in the 2000, I think. They saved over $500,000 in foundation. Wow. So just by doing that. So yeah, we can correlate it to strength of rock, and it's just a matter of building those databases and learning how to drill.
Right. So the local correlations can definitely be valuable. And I think I know that people want like a quick correlation, and it's unfortunately not that straightforward. But I mean, Mike Rogers' work is really interesting, and I think could help, like, from a preliminary design standpoint, maybe.
Yeah.
But yeah, a lot of it is about getting data in your area and doing sort of your own regional correlations, which I think is can feel like a hurdle to some people, but also is going to result in a lot better strength data in the long run.
Yeah, and you're testing with the MWD. I consider MWD as an in situ test. You're testing a lot more material than you would if you were taking samples and bringing them in the lab. So you can test all over the site, in aerial extent and in depth extent.
Yeah, that makes sense. So once you have it, once you do those correlations, you have the information for so much material. There was another one here. Oh, what resources do you recommend to start learning how to use MWD for design?
What design?
That's a tricky question. I'll let you take it where you want to take it.
Well, I mean, I don't think we're there yet. For design, I think we need to gather a lot more information and a lot more comparison with traditional data and what we get from MWD. But I don't know that this. I know this question had two parts. When you need to get started, well, you need the equipment. But
yeah, we can get. I have one more question up here, but I will table it for a minute. So related to that, say a state DOT representative or a consultant asked, how do I get started? What information and resources would you be able to provide? And what is sort of a baseline cost for equipment, and the training needs that would be required?
Okay, well, you need the equipment. If you want to get started, I think the best thing to do right now is if you're a novice, so this is the first time you hear about this, I would urge people to join the MWD users group that's hosted by DFI. We meet every month, and we have usually have some presentations from engineers using the system, from companies fabricating the equipment. looking at standards, just having general discussions in there. And it's really a great place to foster that cooperation and learning environment. So that would be the first thing. And then, I get calls all the time. People say, hey, what do I need to get and all that. I just try to help them out and steer them in the right direction. As far as you might be interested in cost, it maybe in the neighborhood of $30,000 to $40,000 to get the whole system on the rig. So that would be with, I think, with the installation. And I've done, I think, 4 or 5 installations, and they're relatively simple. And the training is also relatively simple. I think, everybody has an iPhone. It's not any more complicated than an iPhone, And then if you have a question, you can always get online, and we've had questions, new additions that we've had, and we get on the phone with Jean-Luc, and they tell us exactly what to do, and they can actually connect to the system and see what we're doing in the field, which is very, very helpful. Yeah, training the crews is really not difficult. I think once they get over that hurdle, that what is this thing? What is I think some drillers are a little skeptical sometimes. They think this is going to be something that's going to be watching them. How much production they do when they do it, but that's not the object of MWD. We're really there to gather the information and help with the system. And I think one of the big thing for me is having that communication with the driller. I think it's very important. Too often is like the driller's somebody that's putting a hole in there, and you don't really talk to that person too much. You do your own thing. No, this is collaboration. You're working with them and say, hey, what do you think? Let's try this rotation rate, see if we can get something a little bit better. And they're the ones I work with, they're really willing to do that. And they see, oh, this is great. Maybe I need to put a little bit more water in there. Maybe I need to do this or to do that. So.
Yeah, it turns the driller into like somebody who you're working with to gather valuable information rather than like just relying on to get to the next sample depth. And
right. Exactly.
I think that could really sort of create more of a partnership, which I think is a really cool outcome. And then from there, kind of think about where it could go for design parameters and those types of the benefits. I feel like people always often look at it from a design standpoint first, and if you can't do something there, well, then why bother? But there's so many other benefits.
Yeah. That's the first thing you do for a project. You put a borehole in.
Yeah.
So if we don't start the right way, it's kind of hard to go to the next step. So I think this will really help that.
Yeah. Okay, so the last question we have in here, and people can still feel free to ask more questions, but we don't have too much more time. When using CPT in stratified soils, you sometimes can't get through the gravelly soil to obtain data in potentially liquefiable layers below. So the question is there an application for MWD to be able to help to look at liquefaction potential below a hard layer?
We haven't done that yet, but I don't see why not. You're just putting a hole down, and I think the question brings something up also, is that the SPT, not the SPT necessarily, but yeah, SPT, CPT, all these tools have limitation, and MWD does not have a limitation. You can go through any material. So if we hit a gravel layer, we can go through that. We hit a boulder like we hit in here all the time. We think, oh, is this bedrock? No, it's just an isolated boulder. So we can go through all that material. So there's no limitation in terms of material. And I think to answer this question further, I think as we progress here, we're going to be able to find more and more application. And I should, before I forget here, also, when we talk MWD, it's not always data for a foundation. Maybe we're putting down some instrumentation. We want to put an inclinometer in there. So rather than just doing a hole quickly and put a casing and grouting it in there, we can actually gather information in there and see exactly what's in that borehole, what's in that stratigraphy. So we get information from, using it for different purposes.
Yep. Yeah, very good point. So yeah, we can look forward to liquefaction analysis with MWD in the future. So how do you see MWD playing a role in improving geotechnical explorations? What do we have to look forward to in the future, other than papers telling us how to look at liquefaction?
Well, I think we will definitely improve the drilling. I think that's important. I don't think we've paid enough attention to that. It will help in creating boreholes for other tests, Lujan test or pressure meter test or geophysical test. So it will have an effect on improving the boreholes for these various tests also. It will improve our understanding of drilling and how we can make it more efficiently, better quality. Also, we're gonna, as we go forward here, we're gonna determine that maybe we need some different compound parameter. We're gonna come up with different equation that will work for specific applications so that we can go to design. Let's see, we can eliminate the driller's effect, and we can use AI or machine learning also to help us deal with this enormous amount of data, so we can again get to design or get to a better stratigraphy. Eventually maybe we can have measurements more closer to the drill bit. Maybe we'll learn a little bit more that way. As technology improves, we may be able to do different things. But I think what's important also is education. I think we need to introduce these kinds of techniques at the undergrad and graduate level. Mm-hmm. They need to be exposed. When I was still teaching at UNH, my undergrad class, junior level soil mechanics, 101, it was not called that, but I used to call it baby soils. I would get the state or a private drilling company to come in for a week, and they would drill every day from noon till 4. And I would split up the kids in group. And so they had to look at drilling. They had to do SPT. They had to get their hands dirty. We need to do that. We need to introduce that into education. So yeah, I think it's just going to go, we're going forward. There's a lot of momentum. It's really exciting.
Yeah, and there's going to be an ASCE standard at some point too, right? So
yes,
then that will help provide guidance to maybe give people more confidence in exactly how to do it.
I think this is, I know, as well, Ben Rivers has been working on that quite a bit, and has used the work of Mike Rogers, and I think that's important. Once we get a standard in there, then people will start doing things in a similar way, have a better understanding of what they need to do, and we'll move that field forward.
Awesome. All right, well, I'm going to wrap up here. I did have Brad put the users group link, so anyone who's interested in joining the users group, there should be a link there in the chat. And Brad, if you could also put the link to a while back, I did, Jean helped with this. I starred in an A game related video that gives a 5-minute intro on MWD in kind of a fun format. GEI Consultants put those together for FHWA. So that's also a great resource to pass around, to a little plug there. But that's all we have. And Jean, thank you so much for your time.
My
pleasure. It was fun to interview you, and I hope everyone got something out of this.
I hope so. Thank you.
We did have one person come in at the end there and ask what's the timetable for the AASCE standard? Is there one yet?
Do we know the timetable for it? I know it's in development.
It's in development. So I think 2024 we'll see the standard.
All right.
Good. That's a perfect way to close it out then. What great interaction today. And this, guys, I got to tell you, this kind of hit it all for GeoStrata Extra, right? We got tons of questions. You guys did the promo for the magazine. We got a Ralph Peck story, which I did not see coming. This was fantastic. So for all of our viewers out there, if you liked what you saw and you're here at the end, so you probably did, again, click like, subscribe, and get notifications. And if you do those things, we will let you know every time we post something to the YouTube channel. We do, of course, have one live stream left in 2023. It is 48 hours from now on Thursday afternoon. It will be Geo-Congress 2024 sneak preview number 3 with Monique Anderson from Shannon and Wilson talking about the Alaska Wave Viaduct project. And you can, of course, register for that on our Eventbrite and all of our other upcoming live streams as well. Mary, great job. Jean, great job. You guys, the chemistry was palpable. I feel like this was an excellent interview. You guys did a great job, even overcoming the technical difficulties. So thank you for doing that.
Hey, I can set up an MWD, but this is a little harder.
Teams came later. It's okay.
Yeah.
And our producer today was Sean Herpelsheimer, and we will see everybody out there really soon.